Today we're going to talk about replacing the battery in a Corsair HC318R. This one is very dead. You turn it on, does nothing. You plug it in, also does nothing. We're going to replace this battery. So for that, you'll need your dead trimmer, a couple of new batteries, and some solder, maybe some side cutters, screwdriver for prying, a solder pump to help with the desoldering of the old batteries, and also a screwdriver to open the hair trimmer. So we'll start out by opening the hair trimmer here. There are 3 screws, one in the back here. I'm going to pop this head off here. That was a screw from the back. And we have 2 more up here. You'll notice the screws are different lengths. The 2 shorter ones go up here and the longer one goes down here. So this will now pop open. You can remove the cover here. There are 2 more screws here to remove. So I'm just going to dump the whole bit out here. Should just slide right out. This little charging port, I need to pull that out as it kind of friction fits in there. So what I'm going to do is desolder these, and then I'll be able to pry the batteries out. They're glued in. So using a hot soldering iron and a solder pump and a fan, I'm going to desolder these pins. There we go. There we have one of our batteries. This other one should also be clean by now. And you can see that glue kind of pulling away here. So there we go. We have 2 nickel metal hydride batteries. They're AA size, 1.2 volts, and a capacity of 900 milliamp hours. So I'm going to get rid of those, and I bought 2 new batteries, same AA size nickel metal hydride. They claim a larger capacity, more than twice as much, 2200 milliamp hours, but the same 1.2 volts. And I would highly recommend getting these with leads already on the battery. It makes the whole process a lot easier, and you don't have to solder anything onto the terminals of the battery, which could potentially heat it up. They have U clips and Z clips, and this is the U clip style. Z clip, this one would be going out this way. This is our negative end, this is our positive end, and our circuit board is labeled. Both of the positive ends are on this side, both of the negative ends are on this side. They run in series, which you can see here on the back. I'm going to use some double-sided tape to help hold them in place. Just lay a piece of double-sided foam tape here across, so that should hit both of the batteries and help hold them in place. Oh, these holes are not quite big enough. You may not run into the same problem. Your tabs might be the right size, but these are unfortunately not the right size. So again, making sure I have my plus lined up with the plus and minus lined up with the minus. I'm going to slide those leads in, press it into my double-sided tape. Now I have 2 leads here ready to be soldered. And I'm going to use my alligator clips here, hold that in place. Now I will trim up the tab on my second new battery. I found this worked pretty nice last time. So I finished trimming both of these tabs, and for the holes that those leads go into on here, I had to open them up a bit, and I did that with just using the tip of these tweezers here so that they would fit. And now I am ready to insert the battery finally. So there's the positive end and our negative end. And I'm just going to pull that through. Great. And I'll solder those two in place. So that's all soldered up. I can try to turn it on now, see if there's any charge in those batteries. Certainly is. That runs way better on those batteries at who knows what charge than it did when it was just plugged in with super dead batteries. So that is ready to be put back in. I might actually just trim these tabs a little bit first in case there's any tight clearances in there. So there we go. I trimmed those tabs off so they're not sticking out quite so far. We can also check that this charging function works. I guess we won't really know, but the light lights up. These are rechargeable batteries, according to the website, and they're the same voltage as the old ones. They're the same battery type as the old ones. They're a larger capacity, so the charging will take longer. So I'm going to do a quick wrap of electrical tape because these batteries do have a little bit of movement here, and I just want to make sure that they don't vibrate and like have the contacts break or something. And these little slots fit into the plastic housing, so I want to avoid those. That's where they come in, right here and here. So I'm going to put this in place. There we go. Motor slips in right there. I can secure the motor in place with these same screws. And I still have the switch here in place. I'm just going to move it over here so I can align it. A little bit tight in there with the batteries. This port slides in there, and put the cover back on. Make sure that LED is lined up in the hole. There we go. And that it sits flat. Everything works. And I will close it back up. The two shorter screws go up here. And the longer screw down here. Throw our cutter head back on. Good as new. For anyone interested in finding out more about how this particular trimmer works, I took some pictures of the internals and made a simulation of the circuit online. Because it's just a single layer PCB, it's easy to follow the traces and figure out how it works. The two batteries are wired in series, so they act as a single battery with a nominal voltage of 2.4 volts and capacity of 900 milliamp hours. This is with the device switched off and the power supply disconnected. This diode prevents the batteries from powering up the LED. In this circuit, it will only come on if it is connected to an external power supply and the device is switched off. These diodes prevent the batteries from creating a potential across the two poles of the charging port when the device is switched on. If those poles were shorted with the device switched on, that would short circuit the batteries and could damage the device. In case the device is switched off, it would simply drain the batteries rather than creating a short circuit since there's a resistor in series. When the power supply is not connected and the device is switched off, there's no current flow. When the device is switched on, there's current flowing through the motor. When the device is connected to the external power supply and switched off, the LED illuminates and the batteries charge. When the device is connected to the external power supply and the device is switched on, current flows from the power supply through the motor and chops your hair off. I wish you luck in bringing your old hair trimmer back to life instead of just buying a new one. And if you have any helpful tips for others, please leave them in the comments below. Thanks for watching.